7.3, solving rational equations. Our goals today, review least common denominators. So if you remember when you have to add fractions or subtract fractions, you can't do that unless they have the same denominator. So remember, we usually multiply them by each other. And so then we get 3 over 6 plus 2 over 6, and then we get 5, 6. So least common denominator, that's what we need to do in order to solve rational equations. Also, extraneous solutions. So as we're changing around the denominators, sometimes we had an excluded value in the original that might show up in our solution set, and we have to just go back and make sure that we're not accidentally using an excluded value. So avoid excluded values is kind of the main idea here. And then we're going to actually introduce steps to help you speed up the solving rational equation process and check for those solutions, and then we'll look at them in application. So that's what we're going to do today. By the end of the day, you should be able to do all those goals. All right, instead of going over the steps first, what I want to do is just jump down to example 1 and go through it and then look back at the steps. So what I want you to do is just see how would you approach this on your own. Before you read through the steps, before we talk about it, just pause this video and either in your guided notes or write this down on a piece of paper, try this. All right, so welcome back. I don't know what method you tried exactly, but I'm going to teach you a method, and it might be very similar to yours. It might be a little different, but this is probably the most effective and efficient. But like I said, there's many methods, so if you like your method that you used, stick with it. Go for it. All right, so what we're going to do is we're going to try to get x alone, right? That's what solving means. So our goal is to figure out what value x should be so that we can plug it in and get the answer of 10, of course. So the problem is x is held in a fraction. So my goal is to get rid of these denominators. And so what I do is I think, what if I were to add these, what would my common denominator need to be? And usually it's by multiplying them by each other, unless they have something in common, but 2 and 3 don't have anything in common. So I'll just multiply them by each other, and 6. And so what I do is I multiply the entire equation by 6. And this will make everything bigger by a factor of 6, so we're not really changing the equal sign or the value of x itself. So this is okay math. So sometimes I do this step a lot quicker, but I'm going to try to show you everything here. So I multiply by 6 all across the boards. And then, as you notice, when I try to simplify this, 6 divided by 3 is 2. 6 divided by 2 is 3. And my fractions are gone. So by multiplying by the least common denominator, I know that it will simplify every single denominator as I work my way through, and then it just turns into like 7th grade math problem. You know, these, when we did a lot of these back in 7th grade. So I combine like terms, and then I notice 5 is multiplying 2x, so I got to divide by 5 to get x alone, and final answer is x equals 12. There were no excluded values, so I know that this is a solution, but I am going to show you that we will like to check just in case. So 12 divided by 3 is, wow, 12 divided by 3 is 4, and 12 divided by 2 is 6. 4 plus 6 does equal 10, so it checks out. So yes, this is a solution. All right, so these are the steps to be, I think, the most efficient on solving these and save yourself a lot of headache with getting the common denominator and then adding, and it'll save you a lot of multiplication as we get a little bit more complicated problems. So first, we will factor. We didn't have to worry about this here. But we'll factor the denominators to help us find that least common denominator. Then we distribute, like I did right here. We distribute that least common denominator to everything, but I'm going to show you how we'll speed that up as it gets a little bit more intense. Then we just solved, and then we checked our answer, and we determined that it was a solution. All right, let's look at another example. So right here, again, my goal is to get x alone, and so I'm going to find the least common denominator, which is most effectively found by just multiplying the denominators by each other. So what I'm going to do, again, is I'm going to multiply everything by 9x, technically over 1, so that's why my denominators stay the same, because I'm just multiplying 1 to everything, 9x to the numerator. So I'm going to get 9x over x minus 9x squared over 9 equals 0 times 9x, which is 0. Now, notice those x's will cancel out, those 9's will cancel out, leaving us with 9 minus x squared. So, goal is to get x alone. The problem was that we had an x in the denominator, x in the numerator. So if we could get rid of those denominators, then it'd be back to more stuff that we're used to, right? So that was the goal there. All right, so now I'm going to just solve like we did last year. Take the square root of both sides. That gets rid of our square, but also creates a plus minus. So I have positive or negative 3 equals x. Now my excluded value was 0, so I know that these are solutions. I could plug them back in, but I can also check my excluded values. That'll be good also. All right, let's do another one. So I suggest you pause this, try B on your own before we move on, and see how you do. All right, so I'm going to look at every denominator and try to find my least common denominator. I know that 2 will multiply to create 6, so I'm going to leave the 6, and then there's some x's in there. So 6x, I could multiply this by 3 to get 6x. I could multiply this by 6, multiply this by x. So just showing that they can all become 6x. That's the least common denominator. So instead of multiplying them all by each other, I can look at the numbers, figure out what's the least number, but that both of these can multiply to create, well, that's 6, and then make sure they all have at least one x. Least common denominator, 6x. So I'm going to multiply 6x through, which will give me 30x over 2x, not 20, 30x over 2x minus 6x over x equals 30x over 6. So 30 divided by 2 is 15. X divided by x is 1. So 15 times 1 is 1. Minus x divided by x is 1. So negative 6 times 1 is negative 6. And then 30 divided by 6 is 5x. Now 15 minus 6 is 9. And then I'll just, divide by 5 to get that x alone. So x equals 9/5. Now let's double check. It looks like my excluded values were just 0. So this is a solution. You always need to check those excluded values. I mean, we haven't had a problem with it yet, but always check those. All right, this one's getting a little bit more interesting, right? Our denominators are now binomials, so a little bit more complicated instead of those monomials. So notice that these guys already have x plus 4, right? So we don't have to worry about multiplying them by each other because they're already the same, okay? And this guy over here is the only one that's different. So we will have to multiply those by each other. So we'll have to get an x plus 1 technically times an x plus 4 to get the same common denominator. Technically we'll need an x plus 1 here, right? X plus 1 here. Then they'll all be the same. But we're not going to do that, right? So we're just finding our least common denominator and then thinking, all right, so if I multiply this by the least common denominator, what's going to happen? So you can skip some steps, but I'm going to write it all out. So I'm just distributing my least common denominator. Imagine it's right here, so I'm distributing it, distributing it, distributing it. So like I said, you might find techniques to help you speed this part up. I'm, like I said, showing every step that I take just to make sure that everybody's clear on what's going on. So notice I have an x plus 1 times x plus 4 that multiplied to every term. Alright, so then I'm going to go through and cancel out, and you're going to notice we don't have fractions anymore, right? So I'll get x squared plus 4x plus 3x plus 3 equals, and then I'm going to multiply these two together, x squared plus 1x plus 3x, that's going to give me 4x's, plus 3. Okay? Now, I'm going to try to get everything, all the x's together. So I'm going to minus x squared. So that goes away. I'm going to minus 4x. What I do to one side, I have to do to the other. That also goes to 0. And then I'm going to try to get, so I already have an x here. And I'm going to move this over. So that goes to 0. So I have 3x equals, that goes to 0. I divide by 3, x equals 0. Now I've got to check what my excluded values were. It looks like they were 1, oops, negative 1, sorry, solve, right, and negative 4. So this is not part of the excluded values, so we're good. This is a solution. Okay, D. Again, I suggest you pause this, try it, see how you do, and yeah. Alright, so if you try this, hopefully you noticed the least common denominator is x plus 2. They're already common. So I'm going to multiply the whole thing by x plus 2, which will, as I multiply those will cancel out. So leaving me with x minus 1 equals x squared plus 2x minus 3. And again, I'm going to try to combine like terms. So I'm going to add 1 and subtract x, which gives me 0 here, right? And then I have x squared plus x minus 2. Now, as I try to solve this, I'm going to notice, oh, I have two different types of x's, so I can't solve just by trying to get the x alone. I'm going to have to use some different techniques, either solve by factoring, quadratic formula, and I'm going to solve by factoring. So I noticed that my a is 1, so I can actually factor this really quickly by just thinking what multiplies to give me negative 2 but adds to give me 1, and I decide 2 and negative 1. So as I solve these, I set them equal to 0, and I get negative 2 and 1. So now as I go back and remember my excluded values, I only had one excluded value, it's negative 2, so that is actually not a solution to this. I mean, it popped up as we're solving, but the only solution is 1. X cannot be negative 2 for this original equation. As we did the math, we undid the fractions, and so because we undid those, the solution still popped up even though it is an excluded value. So that's why you always have to check, because mathematically, as you break up that fraction, it'll still give the solution even though it's an excluded value. So always check. Alright, E. Okay, so least common denominator. Looks like we're going to have an x minus 3 and an x plus 3. Right, so we'll multiply these by each other. And then I'm going to, instead of having to multiply it by this also, I'm going to factor this. And because it's a difference of squares, I can factor it really quickly. I notice, oh, this guy already has that entire denominator that I'm going to create. So I actually don't need to multiply anything there. So I'm done with my least common denominator. So I'm multiplying this whole thing by x minus 3, x plus 3. And I'll distribute that in. So that means this will cancel out, but it'll leave me with an x times an x plus 3 as I distribute that whole piece in, right? So x minus 3 cancels out, leaving me with x times x plus 3. Now when I multiply this over, the x plus 3 will cancel out, leaving me with x times x minus 3. And as I distribute it, it'll cancel out with the entire denominator, leaving me with 2. And I am going to now distribute. So I get x squared plus 3x plus x squared minus 3x equals 2. I'm going to combine like terms. Those go to 0, leaving me a 2x squared. Divide by 2. I get x squared equals 1. Take the square root of both sides. X equals plus or minus 1. My excluded values were 3 and negative 3. And so that's fine. I have two solutions here, 1 and negative 1. And we could plug them back in and double check, but they do work. I already checked them, so I'm not going to make you watch me check them. But just like we said earlier, over here, like notice, you just plug those values in and see if they give you the solution. One more. I'm going to factor this. And, yep, it has the exact same pieces. So my least common denominator will be x plus 2 times x plus 1. So remember, I'm multiplying this to every piece of that function. So in the first one, we had x minus 1 times x plus 2 times x plus 1. What did I do? I kept this and remembered that I was distributing this in here. I'm going to distribute it here and here. Okay? Don't forget the shortcut that I showed you earlier. I'm again showing you the whole process, but the shortcut will save you a bunch of writing, right? So we have 2x times x plus 2 times x plus 1. This is right here, right? I'm distributing it there, and that's all over x plus 2. So the denominator will stay, of course. Sorry, kind of jumping. Equals x minus 1 times x plus 1 times x plus 2 all over x plus 1. So this cancels out, leaving us with x minus 1 plus, this cancels out, 2x times x plus 1. This cancels out, leaving us with x minus 1, x plus 2. So that's going to give us 2x squared plus 2x plus x and negative 1. And on this side, as I use the distributive property of the box method, I'll get x squared plus x minus 2. Okay, so now I am going to combine like terms and see what happens. So I'm going to minus an x from both sides. That'll go, right? And then I'm going to add 1, I guess. Actually, sorry, I want to add 2. I want to move this 2 over, so that goes to 0. That'll give me that. And then I'm going to minus this x squared. Kind of got a little messy, I apologize. So I have 0 on the right-hand side, and then I have an x squared plus 2x plus 1. And I'm going to factor that. And so something that multiplies to give me 1 but adds to give me 2 is x plus 1 times x plus 1. And so x equals negative 1 as I solve. So now I'm going to, that's my answer, right? So I'm going to look up here and look at my excluded values. So x, sorry, pen problems. X could not be negative 1 or negative 2, and our only solution was negative 1. So that means that there is actually no solution to this guy. Okay? All right. So go to the homework, try this. There are a few word problems, so I'm going to go over those right now. but you could probably do it on your own if you'd like, or you can stick around. All right, so you ride your bike to a store. It's 4 miles away to pick up things for dinner. When there is no wind, your ride is 10 miles. You go 10 miles per hour. Today, your trip to the store and back took you 1 hour. So we know the total time was 1 hour. What was the speed of the wind today? So you got to remember, time equals distance over rate. So we traveled 8 miles, and normally our rate is 10 miles per hour, but we need to subtract that wind that was making us go slower. So what I'm going to do is solve for W. So what I can do is I can multiply both sides by the least common denominator, which is 10 minus W. Now when I multiply 10 minus W here, it'll cancel out, right? When I multiply it here, it'll multiply by 1. So I'll have 8 equals 10 minus W. Okay, if I minus 10, I'm going to get negative 2 equals negative W. Divide by negative 1. W equals 2 miles per hour. That's my rate of the wind. Okay. So distance equals, or time equals distance divided by rate. Okay, John is kayaking in the Russian River, which flows downstream at a rate of 1 mile per hour. He paddles 5 miles downstream and then turns around and paddles 6 miles upstream. The trip takes 3 hours. How fast can John paddle in still water? All right, so when he's going downstream, he's paddling, but he also has the current taking him, right? So he goes 5 miles, and he has his rate plus that 1 mile per hour that's increased because of the stream. Then when he turns around, this is time, so we're adding the time that it takes for him to come back. He goes back up 6 miles, and he's going to have his rate, right, that he can paddle, but the current's pushing on him, so it's going to be that negative 1 mile per hour there. Okay, so now all we have to do is solve. So I'm going to find my least common denominator, which is r plus 1, r minus 1. So when we multiply to the first one, that'll cancel out with the r plus 1, leaving us with 5 times r minus 1. The r minus 1 will cancel out, so we'll have plus 6 times r plus 1 equals 3 times r plus 1, r minus 1. And then I'm going to clean this one up. So I'll have 5r minus 5 plus 6x plus 6 equals, and then I'll multiply those. I'm going to get, they are difference of squares, so we'll get r squared minus 1. So I'll have 3r squared minus 3. I'm going to quickly combine like terms, because we've kind of already done this before. And I'm going to get 0 equals 3x squared minus 11x minus 4. Now I'm going to factor that, so I'm going to do 3 times negative 4, my a times my c, but when I factor, I'm going to get, sorry I didn't give you enough room, 3x plus 1 and x minus 4. I'm going to set each one of those equal to 0 and solve, and when I do the first one, I'm going to get negative 1/3, and the second one I'm going to get 4. Now you can't have a negative rate, right, if you're paddling, unless something really crazy is going on. So he can paddle at 4 miles per hour. Okay, next problem. A fountain has 2 drainage valves. So they open the first valve and it's going to drain in 4 hours. Or they could keep that one closed, open the second one, but it's going to take 5.25 hours to drain. So we want to know if they open both at the same time, how long it's going to take to drain. So this is kind of distance time equals distance over rate type of problem, but a little bit different, okay, because we're talking about how long it takes him to do a job. So it's going to take him 4 hours to do that job, so his time, the time it takes him to do that part of the job over 4. So what part of the job will he do divided by the 4 hours that it normally takes him to do the job? Okay, plus the time it's going to take the other valve to do the job, divided by that rate, right, that it'll take them. So what part of the job will they do? And together they should get that whole job completed. So what time of the job will they do plus that time of the job? Normally he does 1/4 of the job every hour. Normally he does 1 out of 5.25 jobs every hour. So we have their rate, right? So t over 4 plus t over 5.25 will give us the completed job. All right, so what I actually did on this is I didn't really like working with decimals because I don't want to. You can, it's not an issue. But I just put in my calculator 1 divided by 5.25, and I hit math and changed it to a fraction. And I got t plus 4 plus 4t over 21. So 4 divided by 21, well, 5.25 is 21/4, so then when we multiply by the reciprocal, we get 4 over 21. All right, so what I did from here is I found that my least common denominator would be 4 times 21, which is 84. And then I multiplied everything by 84. So that 84 times t divided by 4 left me with 21t. And then 84 times 4 divided by 21 left me with 4t. And that equals 84. Oh, there was already that 4. That gave me 16. I was like, I'm missing a number. Okay, so when I do 84 times 4, 84 times 4, and then divide it by 21, you get 16. All right, 21t plus 16t is 37. Then I'm going to divide by 37, so t equals 84 over 37, which is about 2 hours, right? 34 would go about 2 something hours. Okay, I want you to try D on your own. I've kind of talked you through 3, and hopefully you paused and thought about them. But try D on your own. So pause this for sure, give it a try, and then hit play again. All right, so Adam drives 15 miles faster than David. Adam can drive 100 miles in the same amount of time that David drives 80. So I'm going to write that right there. 100 equals 80. This is Adam. This is David. They are equal. Okay? And so what we're going to do, we want to find his speed. And so if we remember, their times are equal. So I'm going to have distance divided by rate for Adam. Distance divided by rate. David is 15 miles slower. I mean, Adam's 15 miles faster, but David's 15 miles slower. Because it wants me to find Adam's driving speed, I'm going to leave R under Adam, and I'm going to do R minus 15 for David, just using this statement here. So now it's just a matter of getting that least common denominator and solving these. So I'm going to multiply, and you kind of have learned this before, so you don't have to use that method, but it is the same process. So we're going to multiply by R times R minus 15. And so when I distribute that in here, it'll cancel out that R, leaving me with 100 times R minus 15. And then when I distribute it in here, it's going to cancel out the R minus 15, leaving me with the 80R. So now distribute. And then solve. So I'm going to add 1500 minus 80R, and I'll get 20R equals 1500. Then I'll divide by 20, and I get R equals 75. So he's going 75 mph. All right, let me know if you have any questions, but that's it. And then we have a project. So watch for that. It'll be coming out, rolling out on Monday.